Hello, everybody. Welcome to another episode from the RPA Vanguard channel. My name is Andy Menon. In this episode, we are going to take a look at yet another useful feature of UiPath State Machines, and that feature is named Transition Triggers. Let's get started. So what we see here in front of us is a project template that's based on the UiPath State Machines. And if you are familiar with state machines and or are familiar with the Robotic Enterprise Framework, you will recognize that this is a project template for the RE framework, right? I want to talk about this a little bit because I want to point out the differences between what you are seeing here versus what I am going to be demonstrating. So with that, if we start at the top of this framework template, we have the init state, right, in which the process initializes, and then it transitions itself into the get transaction data state successfully. And then what it does is it pulls out a row of transaction data, right? And then it passes that transaction data into the process transaction state. Now, the process transaction state will process the transaction, and assuming that it has successfully processed the transaction, the state machine now transitions back to the get transaction data state, right? And then the next row of data is extracted. It is passed down to the process transaction. The process transaction state processes the data, and if it's successful, it then again goes back to the get transaction data, right? And so what you're seeing here is that this state machine is transitioning between two states, right? And continuously looping back, right? Back and forth. It goes into the get transaction data, goes into the process transaction, loops back, and the process continues as long as there is data to process, right? And in an ideal situation, if all the data has been processed successfully and there is no more data, then this loop breaks and then the state machine transitions into the end process state. So what I want to point out here is that this state machine transitions between two states, right, as long as there is data to be processed. So how different is this from what I am going to be demonstrating, right? So for that, let's step back into the studio project. Now, this is a state machine based project that I have written for the purposes of this demonstration. And I'll get to the use case in a bit. But here you can see that this is a very simple project. It has an initial state. It has the state that actually runs the logic, and then there is a final state. But what you are seeing here on this corner is that in this use case, the state machine loops into the same state over and over again, right? So it keeps maintaining this state as long as it has the business logic to execute, right? And once the conditions to execute the business logic breaks, it then transitions over into the final state, right? So our focus is largely going to be on this transition here, right? That's named keep going, right? And you will see how the concept of transition triggers makes this possible. And hopefully at the end of this video, you might be able to come up with uses of your own for your state machine-based projects. So now let's move on to the use case, because without understanding the rationale behind the use case, it might be a bit difficult for some of us to follow what this demo is about. The use case that I've come up for this demonstration is the classic Fibonacci series. And we all have, at some point in time in our past, maybe during high school math classes or our early college math classes, we would have heard of the Fibonacci numbers, right? And basically, what the Fibonacci numbers are is it's a series of numbers where if you take a given number, it's a sum of the previous two numbers, right? And if we go down to this table here, you will see that there is a Fibonacci series from 0 all the way to 19 laid out. And each subsequent number is a sum of its previous two numbers, right? For example, 1 is the sum of 0 and 1. 2 is the sum of 1 plus 1. 3 is the sum of 1 plus 2. So you get the idea, right? What we are going to be doing is we are going to be writing the Fibonacci series as a state machine, right? And that's what I'm going to be demonstrating. Now, if you are familiar with Fibonacci series and if you are a computer programmer, you know that this is a classic case for recursion, right? So there are a number of ways in which you can write a program for Fibonacci series, but the most popular one is recursion. But then if I take recursion for this demo, that might not be the best best way to demonstrate. That's my opinion. Now, if you want to know what are the multiple ways to write recursion, you could do your research, but I thought that I'm going to ask ChatGPT, right? So I am going to ask ChatGPT if it can write me a program for Fibonacci series, right? So let's get some things out of the way. And I am going to ask. So you see, it completely ignored my instruction to not give me too much explanation, and it just, threw out all this extra text that I really do not need. So this is the iterative way of writing, the Fibonacci series, right? Now, let me try to ask ChatGPT if it can write the same program with recursion. All right, so the one with recursion is much shorter, but it requires a lot of imagination, right, to understand how it works, right? And there are a number of articles on recursion that you can actually go to and read about how Fibonacci series works. But what I have done is I've written something similar to the iterative approach, and I'm going to sketch that out a little bit. So here is the series for Fibonacci of 10, right? There are 11 numbers and Fibonacci of 10 is 55, right? So what I do is I start with a number n1. I start with two integers, n1 and n2. And then the sum of n1 and n2 is the total, right, at that point. So n1 plus n2 is t. Now what I do is I loop through this and I keep shifting the numbers to the left. Basically, as I keep moving to the right, the numbers keep shifting to the left. So what I mean by that is I'm going to take n2 and put it into n1, and I'm going to take t and put it into n2. So effectively, this is how the series is going to shift. n1, n2, and t, right? So you see what's happening here. As I shift to the right, the previous sum of numbers is assigned to n2, and the previous value of n2 is assigned to n1, right? So you get the idea. So what will be our logic, right? If we look at our logic now, I first compute t is equal to n1 plus n2, right? And then I shift to the left, right? Basically, what I mean by that is I put n2 n1 equal to n2, which means I put the value of n2 into n1, and then I put the value of the recent total into n2, right? And then repeat the loop, right? So basically, this loop repeats, right? First, I compute t is equal to n1 plus n2, and then I shift the numbers to the left, and then I go back and compute t. And the process repeats until the limit is hit, right? Until the limit is hit, right? And that limit is this time 10, right? Because we have requested for Fibonacci of 10. And so the process repeats until the total reaches 55, right? So this is the logic that I have used in this project. And I'm hoping that with that explanation and this code, you will be able to understand this example better, right? So now let's go into the topic of transition triggers and how have we used it to keep this state recursively maintained as long as the state machine has the Fibonacci series to compute, right? So as usual is the case, I'm going to demonstrate how this works, and then we can take a look at the output, and then we can go in and see how this works, right? So I am going to start this in run mode. One of the things that you notice here is that the series limit has been capped between 0 to 45, right? The reason for that is, first, this demo deals only with Fibonacci series of positive numbers, right? That's reason number one. The second is all my variables are set to integers. And therefore, if I put in a number greater than 45, it's going to give me an overflow error, right? So I've capped the series up until number 45. You could modify this to change the data type to hold larger numbers and go all the way to, higher range, right? But for now, I'm going to just demonstrate a simple series of, say, 10, right? I'm going to put in this value and I say, okay. So here it is. It says Fibonacci series process has completed. Fibonacci of 10 is 55. Okay, that's as we expected, right? And going back into the code here and looking at the log output, right? I also have put out some log lines that shows how the computation is occurring, just for a friendly demonstration. And that is the reason why I wrote it the way I have written it. So if I pull this log into a notepad, this is how it's going to look like. So if I take this series of numbers and then compare it with the Fibonacci table, you will see that Fibonacci of 10 is 55, right? So we can test this out for different numbers and see how well this code performs, right? Now let's go back into the state machine to check out how this whole thing works. As usual is the case, the state machine starts off with some kind of init state. In this case, this is called the accept user input state, where it accepts the user's input through a dialog and then validates it, right? Basically, what happens here is it's nothing earth-shattering. It's basic code. It accepts an input, right? And then what happens is it figures out if this is a valid integer. If it is yes, then it goes in to check if the input is valid. If it is, then it saves the series limit to, because that is the limit that you have asked. If you have input number 10, then your Fibonacci series limit is 10, right? And it will compute if you have put in a number that's valid between 0 and 45, right? If that number is exceeding this limit, then the state machine ends execution and you will get an error, right? Saying that you have to enter a number between 0 and 45. So if you look at these two constants, you can find them in the variables section, and you will see that I've set the minimum limit to 0 and the maximum limit to 45. So you can modify this to go higher after you change the data types from integer, right? So this is it about the accept user input state. Now, if the state is valid, right, input valid, it goes to the run Fibonacci series state, right? So if I click on this state, it takes us to the second state, which is where all of the action happens. So if I go into the overview, you will see that I am here in Fibonacci series for the limit specified, right? And this is where we are going to be using transition triggers, right? So if I go back in, it does all the basic computation. Basically, if the series is 0 or 1, then it writes out Fibonacci of 0 is 0, Fibonacci of 1 is 1. And then if it is greater than 2, then it starts the computation process, right? So you can go through that. And then you can see how the series shifts, right? And finally, how you compute the series result of N1 plus N2. So this is good, right? Now, it has to keep working until the entire series limit is hit. So what does it do? It goes into a transition called keep going, right? And if this keep going transition validates to true, then it will come back to the same state. You can see that it is feeding into itself. Keep going, back to run Fibonacci series. And run Fibonacci series is basically this state you see here, right? This is the same state it is recursing into. Right. So if I now go into keep going, this is where we are going to make use of the transition trigger. Right. Basically, what I'm doing here is as soon as this transition is hit, right, this trigger activates, right? And I'm going to compute the condition keep going, which will validate if the series has hit the series limit. Right? So there is a counter and it counts up from 0 to the series limit of 10. In this case, let's say it's 10. Now, if this condition evaluates to keep going equal to true, right? Then what happens is the value of keep going is immediately validated here in this condition. So this is some kind of a just-in-time trigger, right? So the state leaves into the keep going transition, it steps into this keep going transition, and then it triggers this code here. This code validates keep going, and then the value of keep going is used to actually run some business logic, right? In this case, I'm writing the Fibonacci series, right? And then I'm shifting the numbers to the left. Like I said, I take N2 and put it into N1, and I take the immediate series result and put them into N2, right? So as long as keep going is true, right, this particular transition keeps going back into the same state. And you can see that the destination is run Fibonacci series, right? And therefore, this is how you use or let me say more precisely, this is one of the ways in which you can use a transition trigger, right, to write conditions of your state machine transitions, right? So in this case now, you're transitioning back to the same run Fibonacci state, right? Now what happens if keep going becomes false? Because this time now, let us say we have completed computing the Fibonacci series of 10. Now the series limit is not true anymore because you're past the threshold of 10. And this time it goes into another transition, right? This is stop. And obviously the condition for the stop transition is not keep going, right? So in the keep going transition, the keep going value is validated, and that value is used here for the state machine to transition from run Fibonacci series to the end state, right? So once not keep going becomes true, it goes into the final state. And in the final state, you have the final result message that is displayed. So if you have entered valid input, right, then you are going to get valid message, right? For example, if you're put in give me Fibonacci series of 10, it's going to show you the final result, just like you saw in the demo, right? And then it's going to log the final result as information. Now, if in case you have exceeded the limit, for example, if you put in -1 or 47, in which case is valid input becomes false, in which case your final state will display an error message, right? So if we test that out, you can see that the state machine almost immediately exits. If you enter a wrong value here, it just straight away jumps through the invalid input transition and goes into the final state, right? So that is pretty much it for this video. And I hope that you have sort of got a brief idea of how to use transition triggers and use that in your own projects. So before I end this video, I just wanted to talk to you about a few things that has got to do with my interaction with ChatGPT, right? So let me go back and bring up a couple of things that I want to show you. First off, if you look at the Wikipedia description of Fibonacci series, and you can see that Fibonacci of 10 is 55, and it goes all the way up to Fibonacci of 19, and it is 4181. And I have pulled various logs on how the state machine works. And here is Fibonacci of 19, right? And you can see that it is displaying the right value, right? 4181. And I've tested the state machine to the end limit of 45. And here is the number. It's a very large number. So Fibonacci of 45 is an extremely large number. And I have clarified that by going to this website, Calculator Soup, which is another avenue to verify your Fibonacci results. And if I put in 45 and hit calculate, you see it does return the same value, right? It's a very large number, but you can see that the output produced by this state machine is also the same, right? So 101.113.490.3170, right? It is the same. So this is good because we are verifying the results of what our state machine can do with other avenues. Now let's go to ChatGPT, produce a new chat, and then ask it to write Fibonacci of 10. It gives me 34, right? You see, based on our verification of the other two sources, this is not the right answer, right? Now, let me ask it another question. You see that it's not always correct because I have asked it before and it has given me the right answer. So one of the things that I want to reinforce is that please do verify your results if you are interacting with ChatGPT, because I almost made a mistake by going through and thinking that Fibonacci of 10 is 34, right? It happens because we do not expect AI to be wrong with at least mathematical results, because the fundamentals of any artificial intelligence technology is some kind of mathematics and the science that has been invented using mathematics. But please do verify your results. But I think it did a good job of giving me the code for Fibonacci series with and without recursion. So I think it did a good job. So this is the first time I've used ChatGPT to produce some content for my channel. But I just wanted to share my experience of the hiccup I ran into because AI is still far away from giving us accurate results all the time, and it can make mistakes. And therefore, when we are building something and trying to use something like an artificial intelligence system like ChatGPT, we have to be a bit careful, right? So I hope that you liked this video, and I hope that you found this content useful. If you did, please do like and subscribe to my channel. I'll truly appreciate it. Thank you, and I'll talk to you soon. Bye.